Hi there, this is Mr. Herman back again with another video. This one's on how zombies spread their viruses, and we're talking about exponential growth. This one takes a while to do, so I'll try to, hopefully it'll fit all in one video. If not, we'll have to post two. We did this just today, 10, 10, 13, in two of the classes, and the third one will be doing it tomorrow. Let's read it together first, then we'll go from there. Have your calculators and pencil ready. So zombies spread their virus very quickly by biting or scratching their victims. After 2 hours of the zombie takeover and eventual annihilation of planet Earth, there were 112 zombies. A mere 4.5 hours later, there were 257 zombies. Assuming that the zombies population grows exponentially, which it doesn't, of course, we all know it's a logistic growth model. We can pretend that it's not for this example. How many zombies will there be after 1 full week? So key things to get out of this first off. Notice that they give you 2 times and 2 months of zombies. So that would mean that like the 2 hours up here is really important. And then the number of zombies that associate with that, which would be 112. So let's put that down first. Kind of like 2, 112. These actually will be points on a graph. We just aren't getting to the point where we're graphing them now. The second amount they give you says 4.5 hours later, there were 257 zombies. Since it's 4.5 hours later, that's a total of 6.5 hours since it started. So you have to add the 2 and the 4.5 here. And then we have 257 zombies for that one. So now the next step is to start by writing out our model. So that starts out, with the y equals y sub o, b to the t. And you do have to know this for the test. There is a problem, just like it's in the test. So be expecting that. That's why we're going over this now. So in this problem here, we need to make sure we're putting everything in the right place. So I've used some colored pens to help out with that a little bit. Since we're talking about this one here, this first one here is, we're going to call this one green, and this one here will be red. So you can see how it works here. We're going to use them kind of together. So the first thing we do is to take the largest time, which is 6.5, and we use its value of zombies as our future amount. So we'll put 257 underneath here. Then we're going to say after that that equals the y sub o, which is normally our initial amount, but it's not in this case. We're going to use it as the initial amount, though. We can do that if we cheat a little bit with the exponents. Then we're going to take b, which we don't know what that is. That's what we're going to solve for here. And we'll take it to the t. T, however, is going to be the exponents. Notice that I started with the green, the 257, so I have to continue off with that and use 6.5 as my first exponent, and then subtract from that to get the other one, which is 2. So what you're supposed to really important that you notice here is that these correlate. This 257 relates to this one, and this one relates to that one. So you have them in the right order. It's really important that you recognize that. Now from there, we'll just start solving. So I can see that 257 is equal to 112 b to the 4.5. And again, just simplifying one thing at a time. Then we can take and divide both sides by 112. Use your calculators to go ahead and do that. And we get like something along the lines of 2.29. So it's approximately this amount here. Let's go like this. B to the 4.5 is approximately 2.295. So it's an approximate amount. Let's go from there, though. Now we got to find the 4.5 root of that. So in your calculators, you're going to put in, it might still be sitting there in there. If it is, just go ahead and put in caret, and then parenthesis 1 divided by 4.5. And then you get an amount for b. And again, it's an estimate, but we usually round to the nearest tenth, or if there's nothing after tenth, like a 0, like 1.0 something, like 345, we carried a couple out, maybe the thousandths place. So we get about, I believe for this, 1.2 something. So we're going to go with approximately 1.2. Remember what that is now. B is the growth rate. So we use that to help us decide how fast something's growing. In this case, the zombie rate's growing at 1.2 or 120% per hour, which is pretty fast. Okay, the next step is to find y sub o, which we don't have. So to do that, we're going to start with the equation again. And this time, we're going to substitute what we know. We know b. We just found it. So b is 1.2. We don't know y sub o, so we're going to leave that there. And now it's important to just decide. You have to pick one of the 2 points. We talked about in class how it's much easier to go with a lower number to work with than it is larger numbers. So let's go with the lower numbers instead. If you use either of these numbers, you'll get the same answer. It doesn't make a difference. So you might as well pick the lower number because it's easier to work with. And we're going to use the time 2 right here. And then the 112 is the future amount. Now I know it's a little confusing because we use 112 for y sub o over here, but that's because we didn't have y sub o. We had to use it and subtract the exponents up here. So go ahead and find out what 1.2 squared is. And that's 1.44. So we get 112 equals y sub o times 1.44. And go ahead and divide both sides by 1.44. I believe you get something along the lines of around 77.7 repeating. So since we have 70, if it's 77.7 repeating, we really can't work with that because that's supposed to be a whole number of zombies, even though zombies might not be whole things. We're going to assume that they are because they're kind of like people. So we're going to take and round up to 78. So y sub o equals 78. Now after this, the next part is to use our model and write our equation out. So when you write the equation out, we'll write it out again. I know we keep doing that, so you get kind of used to that by now. What we're going to do is we're going to take and leave y and t here alone. So just, I'll put them like this, y equals, and put the t up here. And then we're going to replace the y sub o and the b with the 2 amounts we found. Y sub o is 78, and b, it's a time sign, b is 1.2. So now what I've got is I've got a model I can use to put any amount of time I want in, and it will tell me, based on the number of hours I put in, the number of zombies, y, at that given time. So the last part of the question says, how many will there be after 1 full week? Well, 1 full week, we have, this is in hours, so I got 24 hours in a day times 7 days in a week. And that's 168 hours. So we need to put that in place of t in that problem right there. So y equals 78 times 1.2 to the 1/68th power. And we find we get 1.56 approximately times 10 to the 15th zombies. More than the population on the Earth. So once again, it's not. That's why it's not exponential growth. It wouldn't be logistic growth, but hopefully they'll find a cure for the zombies before they get out of hand.